There have been some questions about how to build a vector addition diagram. In this video, I'll take you through a couple of examples on some generic vector addition diagrams. Let's go ahead and start with two vectors, an A vector pointing up and a B vector pointing down. These can be any type of vector. For the students currently in balanced forces, you might recognize these as force vectors. To add these together, we'll connect them head to tail. Notice A and B are just about on top of each other. When we go up 8 squares with the red, followed by down 8 squares with the blue, or a result of 0. So for this one, two vectors A and B added together results in 0. To make it a little more difficult, and we'll take two vectors. A is up 8 squares, and B is to the right 3 squares. When we add them together head to tail, we end up with a result that is pointed up and to the right. So the resultant of A plus B is just R. Notice that R has a tail here, goes over 3 and up 8, and its head ends there. We'll try another little bit more difficult. A is now pointed off into some other direction up and to the right, and B is directly to the right. When we add them together, A plus B as vectors, head to tail, we end up with a long resultant vector R, and graphically we can see that R looks like this. Now sometimes we end up with more than two vectors that need to be added together. Here's an example of 3. This almost looks like a free body diagram with 3 vectors originating at one position or at one place in space. We can slide these vectors head to tail again and end up with something that looks like this. Again, adding head to tail all the way around from A to B to C, our resultant from here to here is R. I'll just replace it over here. Now there's another way to look at this, and some students like the concept of adding vectors together using components, or recognizing the magnitude of the vector up and down and the magnitude of the vector left to right. Here's an example of vector addition by using components. I've left the whole thing unveiled here so you can see that A plus B plus C is still R. But in this case, I've taken the A vector and I've broken it into a Y component, or an up and down component, and an X component, or left to right component. Sometimes this is referred to as vertical or horizontal components. Now if I look at everything that is going up and down, I have my AY up and C down, but the result is 4 up, because 8 up plus 4 down is 4 up. The same thing can be said about left and right. I have 3 for my A sub X, and 3 for my blue, and I end with 6 to the right. That tells me that the resultant must be 4 up and 6 to the right, and I end up with a resultant vector that looks like this.